Alright ladies, for the second video, notice I'm back on School Fusion. I'm going to take a look at the 6.4 Transformations link out of the second semester applets. And it should look like this. Now it would be a good idea for this to have sine and cosine open. You can ignore the rest. Notice if I click next to sine, it turns sine on. Cosine likewise, it is going between negative 2 pi and positive 2 pi when you click on it. We go ahead and turn cosine off and just focus on sine. Now you notice that I'm going to close sine actually so you can see more of it. If I also have the fancy sign, y equals a times sine bx minus c plus d, I can use the sliders down here to adjust the function. So for our second part of the notes, this is the 6.4 transformations. You have a chart that looks very similar to this, and it says if this is the graph of y equals sine of x, what is the graph of sine of x plus a constant equal? So for instance, sine of x plus 2 and sine of x minus 2, what happens there? So what we're going to do is go to our website, and the plus 2 minus 2 be adjusting d. So let's go down to the d slider. And if I make d positive, what happens? Well, it looks like it's shifting up. So add 2 would mean d equals 2. The function shifts up 2. Whereas if I do minus 2, then the function shifts down 2. So what I would recommend doing is for those visual people, might be a good idea to snip the graph. So red is the original, blue is the shifted version for each of that. Or if you are more of a verbal person, you can go ahead and write just a verbal description. What happens? Well, the plus 2 moves it up 2, the minus 2 moves it down 2. So go ahead and play around with the plus minus for D, the plus minus for A, and see if you can come up with some conclusions for those. I would recommend pausing here for a minute, write out or snip pictures of your conclusions, and then we'll check answers in just a minute. Okay, so here we are back. Let's take a look at our answers to playing around with a function. We already talked about the plus versus minus, so move it up, down, or a vertical shift, positive or negative. For changing the c, notice that a plus a value ends up moving it to the left a certain amount. And that is because if you look at our website, you'll notice, let's change d back to 0, that the function is bx minus c. So therefore, when I move c negative, the equation would actually be, for this one, for instance, minus negative 2.6, which would give me plus 2.6. So plus 2.6 moves it to the left, whereas a minus, so if I had c equals 4, that's actually x minus 4 moves it to the right. Okay, so play around with that a little bit more if you need some convincing. But to sum it up, a plus a value here is really minus a negative. That moves it to the left. And then if it's just straight minus, as subtracting, would move it to the right a certain amount. So pi over 4 would be about half a tick mark. So normally for sine, you would have it crossing the x-axis at the origin. So rather than crossing at the origin, it's been the x-intercept has been shifted to the left, about half a tick mark, pi over 4 units. Okay, whereas here, once again, sine would normally cross at the origin. It's been moved over to the right, half a tick mark. Okay, let's take a look at a couple other transformations that are not necessarily exactly the same as parabolas and other functions that we've talked about. The next one on your chart is what happens when you have 3 times a value. Okay, so if I look at my graph, A, B, and C are the same. Let's change A now to 3 and watch what happens. So you see that it makes a vertical stretch. Okay, so positive 3 makes it stretch vertically. If I have in the next line, it's A equals 1/2, so a fractional value. Notice that now it's vertically shorter. It's been vertically squished or compressed. Okay, and then of course if I have a is negative, this takes care of the one at the very end. A negative just flips it. Okay, so positive a that's large, greater than 1, stretches it. A that is smaller than 1 but positive squishes it or compresses it. And then a that's negative would flip it. And then the same thing, as a gets larger negative, it stretches. If a is a fraction less than 1 negative, it would be compressed but flipped as well. Okay, then move a back to 1. There we go. And so that takes care of the next couple. 3 would be a vertical stretch. 1/2 would be a vertical compression. Now the next one is actually looking at what happens if you have a number inside the sine function. So that would be the equivalent of, instead of changing the a, changing the b in our graph. So let's slide the b. So if b is large, okay, look at what's happening. You can see it coming in from the sides. Okay. Whereas if b is small, it stretches out to the sides. You can't get it very far, but a little bit. Okay, so this is one that does not have a direct parallel to parabolas. It's even more unusual than just the comparison of, I guess, the slope is what you could call it when I changed a. When I change b, it actually makes the wave occur more frequently, okay, or it reduces the period, how long it takes for the function to cycle all the way through. So normally, you would have one cycle, if b is 1, you'd have one full wave going between 0 and 2 pi. Okay, so if I increase b to 2, now I have 2 full waves occurring every 2 pi, or in other words, one full wave every 1 pi. If I increased it to 3, same pattern. Now I'd have 3 waves for every 2 pi radians. Okay? If I go in the other direction, so still positive but negative, but fractional, sorry, not negative. So 0.5, or as close as I can do it. Now only half a wave occurs for 2 pi radians. Yeah, so half a wave if my b is 1/2. So that takes care of our next 2. So if b is 2, function will cycle twice as quickly. So you have 2 waves on either side, and this is what it would look like in the calculator. If it's 1/4, you only have 1/4 of the wave. You're welcome to change that to 1/2 here, especially if you're snipping a graph from the website instead of drawing it yourself, just because 1/4 is kind of hard to get from the Desmos website. But change that to 1/2, function would cycle half as quickly, and you would see just the top half of the sine wave, but not the whole thing on the right side of the axis, so going between 0 and 2 pi. Okay. The last one, of course, on the chart is just the negative, which we talked about when we adjusted the b. If you change the sine to a negative sine function, change a to negative, it would flip it. So instead of the wave on the right side of the y-axis going up first and then down, now it's going down first and then up. Okay. Part of what you will be asked to do in this part of the transformation unit is to match. So the second part of the homework tonight is a set of graphs that match with the functions. See if you can use the properties from this chart to match which one goes with which. You do not need to worry about anything else besides the matching on this section. And try to do it, if you can, without a calculator. Check your answers with a calculator if you need to, but try to do it without a calculator. The one caution I will give to you about the homework assignment is that the graph on the book will sometimes not go between -2 pi and +2 pi. So you might need to kind of ignore part of it, just look at the parts between 0 and 2 pi, or extend the graph slightly if it stops, for instance, at 3 pi over 2 or at 1 pi. Don't forget to email me if you have any questions over this lesson. On Tuesday, we'll be doing very similar material, but with the other 4 functions: tangent, secant, cosecant, and cotangent. So you will get these properties re-emphasized. You'll find that the function has very similar the transformation had various similar effects on each function. And so we'll begin class on Tuesday with a review of this, maybe some matching practice, and then go into the other set of functions where it can be reinforced. Enjoy the rest of your snow day, girls. One last thing, just to make sure you don't miss it. You can get the homework assignment out of your book. Email a friend if you usually have a hardback textbook and you have not been able to, or you did not take it home with you. Otherwise, I assume that those of you with the e-text can get this out of there. The first part of this homework is the questions just about normal, sine, and cosine, that you can get the answers from your calculator or from the chart. And the second set is the matching section I mentioned a minute ago.